Some chemical reactions are fast, others are slow. We know a chemical reaction occurs when bonds break and form, so what factors determine how fast a reaction occurs? How can we quantify the speed or rate of a reaction? Let's take a look at these two reactions, salt dissolving in water and methane burning. You've seen these reactions before, so stop the video and answer these questions. And the answers are: both reactions are fast because we can see them occur before our eyes. Heat is released by the methane combustion reaction. Place your hand over the flame and it feels hot. When salt dissolves in water, Hess's law tells us heat is absorbed by that reaction. Also, when you put your hands around the cup where you're adding salt, the cup will start feeling colder. And both reactions occur spontaneously because both reactions occur. If these reactions were not spontaneous, we would not see salt dissolve in water or methane burn. Energy is involved in every chemical reaction. Endothermic means energy is gained or absorbed. Exothermic means energy is lost or released. Stop the video to answer these questions. And the answers are: bonds breaking in a compound is like breaking a stick. You have to supply energy or energy is absorbed for the stick to break. Bonds forming is the reverse of bonds breaking, so when bonds form, energy is released. And if you know nothing about a reaction and had to guess that the reaction is exothermic. Think of a chemical reaction like a demolition derby. Cars are like the atoms or molecules. When the cars collide with enough energy, that means they're going fast enough, something's going to break. In a chemical reaction, fragments from different molecules collide, form bonds to make the products. When we say that every chemical reaction involves energy, what we mean is, does a reaction occur and how fast does a reaction occur? Does a reaction occur involves thermodynamics. How fast does a reaction occur involves reaction rates or kinetics. So a reaction occurs if the energetics are favorable. Stop the video and answer this question. And the answer is: according to thermodynamics, enthalpy and entropy are the two driving forces that determine whether a reaction occurs. If the change in enthalpy for a reaction is less than zero, the reaction is exothermic. If the change in enthalpy is greater than zero, the reaction is endothermic. You've seen or you've burned wood before. Stop the video and answer these two questions. And the answer is: when wood burns, heat is released, so the reaction is exothermic. Exothermic means the reactants are at a higher energy than the products. The difference in energy represents delta H, and the energetics are favorable because the reaction goes in a downhill direction. Each of these 5 reactions occur. Stop the video and determine which reaction is fast and which one is slow. And the answers are: as humans, we want to be able to control things. That includes reaction rates. Here are a few important reactions we want to control. What determines how fast or slow a reaction occurs? And how can we control how fast or slow a reaction occurs? The reaction temperature, concentration of reactants, and a catalyst determines the reaction rate. Now, which factor increases the energy of a reaction? Which factor increases the frequency of collisions? Stop the video and answer these questions. And the answers are: compare a demolition derby to a chemical reaction. Cars, just like atoms, molecules, are in motion, and when they smash into or collide with each other, something is going to break and form. Stop the video and answer these two questions in terms of a demolition derby. And the answers are: cars moving at higher speed is like raising the temperature, which means atoms or molecules are moving faster. More cars in the same area increases the number of collisions, just like raising the concentration. Compare wood burning in air on the left to wood burning in pure oxygen on the right. Stop the video and answer these two questions. And the answers are: the factor that changes rate is concentration. Pure oxygen is a higher concentration than the 20% oxygen in air. So more collisions between oxygen and wood and a faster reaction. Let's take a look at a reaction energy diagram. Here are the reactants, here are the products, and here's the speed bump for the reactants to get to the products. This is like getting from here to there with the mother of all speed bumps between here and your destination. Stop the video and answer these questions. And the answers are: the smaller the speed bump or activation energy, the faster the reaction. You've seen the iron rusting reaction before. Stop the video and answer this question. And the answer is: The iron rusting reaction is slow, so that reaction has a large activation energy or speed bump. What about the diamond to graphite reaction? Stop the video and answer this question. And the answer is diamond is converted to graphite very, very slowly, actually in geologic time, so that reaction has a very large activation energy. So we've looked at the factors that determine how fast a reaction occurs, and we looked at how to describe a reaction using a reaction energy diagram. So let's use math to describe how fast a reaction occurs. So fast or slow refers to speed or rate. In physics, the rate is the change in distance with time. In chemistry, the rate of reaction is the change in concentration with time. Let's look at the wood burning reaction again. Stop the video and spend a minute reviewing this chemical calculation. We want to graph the concentration of wood versus time of reaction. Stop the video and draw this graph. And the answer is, there's a lot of wood at the start of the reaction. As the wood burns, the amount of wood decreases. From our concentration versus time graph, we can figure out the rate. The rate is the slope of the tangent of the line, which equals the change in concentration of wood with time. The minus sign tells us the concentration of wood is decreasing with time. As the reaction proceeds, what happens to the rate? Stop the video and think about that for a minute. And the answer is, as the reaction proceeds, the rate decreases. In other words, the reaction gets slower. Early in the reaction, the slope is greater than the slope later in the reaction. We looked at what happens to the reactants with time. What about the products? The amount of products increase with time of reaction. The rate of formation of product is faster at the beginning of the reaction than later in the reaction. In the next video, we will quantify the reaction rate with the rate law.